To complete the setup of the environment, let's define the materials for the floor, both inside and outside, as well as for the wall behind the mesh. Select the floor planks and press the slash key on the numeric keypad to isolate the selection. Set a perspective view and change the display mode to Material Preview. In the Properties window, open the Material tab. Click on New and rename the material to Floor Planks. In the Shader Editor window, select the Principled node and press Ctrl-T to automatically add the mapping and texture nodes we need. Select the Image Texture node and delete it. Open the File Explorer window and navigate to the folder containing the textures to be used during the course. Locate and select the three textures: Wood Floor Color, Roughness, and Normal. Simply drag and drop them into the Shader Editor. To ensure a clear and organized view, it is essential to arrange the color, roughness, and normal nodes in this precise vertical sequence. This alignment ensures that the connections to the respective channels of the principled BSDF node are made without crossing, thus keeping the layout tidy and easy to read. Now connect the respective input vector channels to the output vector channel of the mapping node. Click on the color space channel of the roughness and normal nodes and set the option to non-color. Connect the color output channel from the color texture node to the base color input channel of the principled node. Connect the color output channel from the roughness texture node to the roughness input channel of the principled node. Connect the color output channel from the normal texture node to the corresponding normal input channel of the principled node. Once the various nodes are connected, we need to adjust the texture. First, let's set an appropriate scale. In the mapping node, set the X and Y values of the scale parameter to 8. To immediately get an idea of the changes we'll make, switch the display mode to solid. Press the slash key on the numeric keypad to make the other elements of the scene reappear. Blender should automatically return to the camera view. If it doesn't, bring it up manually by pressing the 0 key. Set the display mode to rendered. The connection we made between the wood floor normal node and the normal channel of the principled node is not correct, as we can also tell from the dark color the texture takes on. We need to insert the normal map node into this connection. Let's try to understand why. Normal textures contain detailed information such as roughness, simulated by altering the direction of the normals on the surface. These textures are generally encoded in the RGB color space, where each channel, red, green, and blue, corresponds to a direction in the XYZ space. The normal map node converts this RGB information into a normal vector that Blender can use. Without the normal map node, directly connecting a normal texture to the principled BSDF node might not produce the desired effect, as in this case because the principled node expects a normal vector that has already been transformed and adapted for rendering not raw RGB data. Therefore, press Shift+A, type normal, select normal map, and place the node between the normal node and the corresponding channel of the principled node. Compared to what is shown in the reference image, our floor has a coloration that is a bit too reddish. We need to make some adjustments. Press Shift+A again, type Hue or Saturation, and select the first option, Hue Saturation Value. Place the node between the color node and the base color channel of the principled node. Set the hue parameter to 0.52 to shift the texture slightly towards yellow. Also, slightly lower the saturation by setting it to 0.8. Press Shift+A, type Contrast, and choose the Brightness Contrast option. Insert the node between the Hue Saturation Value node and the principled BSDF node. Set the Contrast parameter to 0.15 and the Brightness parameter to 0.05. Now all that's left is to adjust the reflection as well, as seen in the reference image, by observing the area where the potted plant rests. Press Shift+A, type Color, and select the ColorRamp option. Insert the node between the roughness node and its corresponding channel on the principled node. Select the black slider and move it to the right, stopping at a position of 0.15. In the outliner, open the Pavimento collection and select the plane geometry, the plane we added to fill the gaps between the planks. In the Properties window, open the Material tab. Click on New to assign a new material and rename it to Pavimento Fuge. In the Shader Editor window, click on the Base Color field and set it to black. We need to be very careful when setting colors to pure white or black. We should always avoid using maximum values, 1 for white, or minimum values, 0 for black, for various technical and visual reasons related to how colors are managed and displayed. In a realistic rendering environment, materials with colors set to the maximum white value can cause clipping issues in the color, where details are lost because white cannot reflect more light than it already maximizes. Similarly, a completely absolute black reflects no light at all, which can appear unnatural because almost all materials in the real world reflect at least some amount of light, even if it's minimal. Setting colors close to but not exactly 0 or 1 allows you to preserve details in the shadows and highlights. By using a very dark gray instead of pure black or a very light gray instead of pure white, you avoid losing details in the very dark or very bright areas of the image. It should also be said that in physically correct PBR materials, it is rare to have extreme values because this does not accurately reflect reality. Therefore, in the final rendering, it is very unlikely that we will achieve a realistic image. For example, even very light materials like snow or paper reflect less than 100% of visible light. This helps create more realistic and natural renders. So, going back to the black color we need to set for the grout lines, it is preferable to set the value parameter to 0.01. We reduce the brightness by setting the roughness parameter to 0.8. With the plane selected, press the slash key on the numeric keypad to isolate its view. Let's change the display mode to Material Preview. Press the Tab key to also switch the working mode to Edit mode. Set the selection mode to Faces and select the strip on the left. In the Materials slot, click the plus button next to the area summarizing the added materials. At this point, Blender will add a new slot. Click on New and rename the material to External Floor. In the Shader Editor window, select the Principled node and press Ctrl-T to add the necessary mapping and texture nodes. Delete the Image Texture node. Open the File Explorer window, select the 3 files, Concrete Floor Color, Glossiness, and Normal, and drag them into the Shader Editor between the Mapping node and the Principled node. Again, make sure to arrange the Color, Roughness, and Normal nodes in this exact vertical sequence. Now, just as we did when setting up the plank material, let's connect the vector channels. Set the color space channel of both the glossiness and normal nodes to non-color. Connect each color output channel from the 3 nodes to their respective input channels on the Principled node. In the Materials tab, click the Assign button to apply the material to the area we've selected. As we can see, the material doesn't look correct. We need to texture this portion. To do this, press the U key and choose the Unwrap Cube projection options. Using Shift+A, we add a normal map node, which we place in the connection between the normal node and the corresponding channel of the Principled node. However, there's a problem with the material we just created. You may have noticed that we connected a glossiness node to a roughness channel, and that's not correct. We need to insert an invert node into this connection. When you connect a glossiness node to the roughness channel of the Principled BSDF node in Blender, you need to add an invert node because the values for glossiness, smooth surface, and roughness, rough surface, are opposites. A high glossiness value corresponds to a low roughness value. To explore this concept further, refer to Lesson 4, Part 2 of Module 2. So, press Shift+A, type Invert, select the corresponding option, and place it in the connection between the glossiness node and the roughness channel. Let's go back to Object Mode and set the viewport to Solid Shading. Press the slash key on the numeric keypad to make all the elements in the scene reappear and return to the camera view. Let's move on to the wall behind the sideboard. Select the 4 panels that make up the wall and press Ctrl plus J to join them into a single model. Set the viewport to rendered mode. Open the Materials tab and click on New. Rename the material to Concrete Wall. Select the principled node and press Ctrl+T. Delete the image texture node. Open the Explorify window, select the 3 textures, Concrete Wall, Color, Roughness, and Normal, and drag them into the shader editor, placing them between the mapping node and the principled node. Make sure they are aligned in this order. Connect the vector channels. Set the color space parameters of the roughness and normal nodes to non-color. Connect each color channel to the corresponding channel of the principled node. Add the normal map node and insert it into the connection between the normal texture and the corresponding channel of the principled node. Switch to Edit mode and select all the geometry. Press the U key and choose the Unwrapped Cube projection options. Switch back to Object mode. In the Mapping node, increase the X and Y values of the scale parameter to 3. The texture appears very bright. In the Shader editor, press Shift+A. Type U and select the U saturation value option. Place the node in the connection between the color texture and the base color channel of the principled node. Lower the saturation to 0.1 and the value parameter to 0.9. Now we need to increase the contrast even more. To do this, press Shift+A again and type RGB. From the menu that appears, choose RGB Curves and place the node right after the U saturation value node. Click on the curve in the graph to create a new control point and move it downwards, specifically to the position x equals 0.3 and y equals 0.15. Click again on another point of the graph line and move the new point to the position x equals 0.7 and y equals 0.8. Observing the French door in the test rendering, we notice that the surface of the glass appears particularly bright. This effect is caused by the reflection of the area light that we placed outside on the surface of the glass. To solve this problem, in the outliner we open the secondary lights collection and select the window light. In the Properties window, open the Object tab, click on the Visibility panel, and under Ray Visibility, disable the transmission channel. At this point, the work can be considered finished. However, I'd like to suggest a touch of creative freedom. Although it's not present in the original image, let's try adding a tree outside on the left side of our scene. The shadow cast by the tree could make the final image more interesting. In the outliner, open the Already collection. Click on the File menu and select Append. Navigate to the file albero.blend, double-click the file, double-click Collection, and then double-click the name of the collection. Select the tree's empty object. Let's move to the location parameter in the transfer window and set these values. X to minus 625 centimeters, Y to minus 245 centimeters, Z to minus 120 centimeters. The effect seems definitely effective to me. Let's save the file incrementally. In the next lesson, we'll focus on implementing light groups, an essential technique for managing and optimizing lighting in rendering projects. We will also delve deeper into the compositing process, exploring how this powerful feature in Blender can be leveraged to further refine and enhance our images.